You ask it a question. It writes you a perfect paragraph. It sounds like it understands. It doesn't. And that's not a flaw. That's the entire design. The headlines say it thinks. The critics say it's just autocomplete. Both are wrong. And after this video, you'll understand why. Underneath ChatGPT is one of the most elegant ideas in computer science. It takes your words, breaks them into numbers, runs them through a mathematical structure called a transformer, and predicts what comes next. One piece at a time. 3 things. Tokens, how it reads. Attention, how it decides what matters. And hallucinations, why it confidently lies to your face. Here's the first surprise. ChatGPT doesn't see words. It sees numbers. Every piece of text you send gets chopped into units called tokens. Then each token is converted into an ID from a fixed vocabulary. GPT-4's vocabulary has about 100,000 tokens. English is efficient. 1 token is roughly 3/4 of a word. But Russian, Chinese, Korean? They eat 3 to 5 times more tokens per character. That's why APIs cost more for non-English prompts. It's literal economics baked into the tokenizer. Tokens aren't just words, they're sub-word chunks, built using an algorithm called byte-pair encoding. Common words get their own token. Rare words get smashed into pieces. This is why the model handles made-up words, typos, and code. Because everything eventually decomposes into tokens it knows. Now the magic move. Each token ID gets mapped to a vector, a long list of numbers, typically 12,000 dimensions for GPT-4. Think of it as a coordinate in a massive space where meaning becomes geometry. Words with similar meanings end up in similar locations. King and queen, neighbors. Dog and stapler, opposite ends of the galaxy. This leads to the most famous demonstration in natural language processing. Take the vector for king, subtract man, add woman. You land almost exactly on queen. The model never saw a rule that said queens are female kings. It learned it from geometry, from the statistics of how billions of words sit next to each other in text. So when you type a message, the first thing that happens is this. Your words are torn into tokens. Each token becomes a vector, and this matrix of numbers is what actually enters the neural network. The English is already gone by layer 1. In 2017, 8 researchers at Google published a paper with a famously bold title, "Attention is all you need." It introduced the transformer. Every major AI model you've heard of, GPT, Claude, Gemini, Llama, is built on this architecture. Here's the problem attention solves. Read this sentence. The animal didn't cross the street because it was too tired. What does it refer to? The animal, obviously. But how does a machine know? It could grammatically refer to street. Humans use context. The transformer's trick is letting every word literally look at every other word and decide which ones matter. The mechanism works like this. Every token generates 3 vectors: a query, a key, and a value. The query asks a question, what am I looking for? Every other token presents a key, here's what I offer. When a query matches a key well, that token's value gets pulled in. It's a content-based lookup, like Google search but for meaning, running inside the network. Mathematically, you compute the dot product of every query with every key. That gives you a raw score, how much each token wants to pay attention to each other token. Run it through a softmax function, and those scores become probabilities. This grid, the attention matrix, is literally the model deciding for every word which other words to weigh when forming meaning. But one attention mechanism isn't enough. Transformers run dozens of them in parallel. GPT-4 uses roughly 96 attention heads per layer. Each head learns a different kind of pattern. One tracks grammar, another tracks subject-verb agreement, another tracks long-range story context. It's called multi-head attention, and it's why these models can juggle so many dependencies at once. Now stack this. GPT-3 had 96 transformer layers. Each layer, attention, a feed-forward network, normalization. The output of one layer becomes the input to the next. As information flows up the stack, the representations get increasingly abstract. Lower layers catch grammar and syntax. Upper layers capture meaning, intent, even reasoning patterns. At the very top of the stack, the model outputs a probability distribution. For every single one of those 100,000 tokens, how likely is it to come next? It picks one. Then the entire process starts over, with the new token appended. That's what generation is. Predicting the next token, 100,000 times a second. We've described the architecture, but an untrained transformer is a box of random numbers. All those connections between layers, the weights, start out meaningless. GPT-3 had 175 billion of them. GPT-4 is estimated to be significantly larger. Training is the process of turning those random numbers into something that can write poetry, debug code, and pass the bar exam. Stage 1. Pre-training. You show the model a staggering amount of text. GPT-3 saw roughly 300 billion tokens. GPT-4 is estimated at over 13 trillion. That's Wikipedia, books, public code, scraped websites, scientific papers, forum posts. Essentially, a large fraction of everything humans have ever written online. The objective is embarrassingly simple. Take a piece of text, hide the next token, ask the model to predict it. Compare the prediction to the true answer. Use the error to nudge every one of those 175 billion weights slightly, so next time, the prediction is a little closer. Repeat, trillions of times, over thousands of GPUs, for months. This is extraordinarily expensive. Training GPT-4 is estimated to have cost over $50 million in raw compute alone, tens of thousands of NVIDIA H100 GPUs running continuously for months. It's why only a handful of companies in the world can do it from scratch. But a pre-trained model isn't ChatGPT yet. A raw pre-trained model can be rude, rambling, or confidently wrong. Stage 2 is called reinforcement learning from human feedback, RLHF. Humans rank the model's responses. A second model learns to predict which responses humans prefer, and the main model is fine-tuned to maximize that preference. This stage is what makes ChatGPT feel helpful instead of feral. Pre-training gives you intelligence. Fine-tuning gives you alignment. Now the uncomfortable part. Ask ChatGPT about a niche fact, a recent event, or an obscure person, and it may give you a detailed, confident, completely wrong answer. Fake citations, invented quotes. Papers that don't exist. This is called hallucination, and it's not a bug. It's baked into how the model works. Remember, the model isn't retrieving facts. It's predicting probabilities over tokens. When you ask something well represented in the training data, the correct token dominates the distribution. But when you ask something rare, obscure, or recent, no single token dominates. The model picks a plausible-sounding answer. It has no internal flag that says, "I don't actually know this." This is the calibration problem. The model's confidence, how certain it sounds, has only a weak connection to whether the answer is correct. It was trained to produce fluent, human-like text. Fluent text sounds confident, so the model sounds confident, always, even when hallucinating. There's also the knowledge cutoff problem. The model's training data stops at a specific date. It has no idea what happened after that. But it will still answer questions about later events by generating plausible fiction. This is why modern systems like ChatGPT and Claude use web search tools to check their own outputs against reality. 3 techniques are actively used to fight hallucination. 1. Retrieval augmented generation. The model pulls real documents from a database before answering. 2. Tool use. The model calls external APIs like web search or a calculator and grounds its response in real data. 3. Chain of thought reasoning. The model is trained to think step by step, which reduces confident errors on multi-step problems. None of these fully solve it. All of them help. The core insight. ChatGPT was never trained to tell the truth. It was trained to predict plausible text. Those are overlapping goals, but they are not the same goal. Here's the mental model to walk away with. LLMs are extraordinary at tasks where plausible and coherent is most of the value. Writing drafts, summarizing, translating, brainstorming, code scaffolding. They fail, predictably, when the task requires exactness, recency, or verified truth. Precise math, legal citations, recent events. Questions where being 99% right looks identical to being 100% right, but matters entirely. Another real limit, the context window. The model can only see a fixed number of tokens at once. GPT-4o handles 128,000 tokens, roughly 300 pages. Claude handles 200,000. Gemini pushes past 1 million. But there's a catch. Performance degrades with length. Models are measurably worse at finding information buried in the middle of a long context. It's called the lost-in-the-middle problem. Real, documented, annoying. And something genuinely strange happens as these models get bigger. Capabilities appear that weren't explicitly trained for. GPT-2 couldn't do arithmetic. GPT-3 could do simple, multi-digit math. GPT-4 handles multi-step reasoning. These are called emergent capabilities. They weren't programmed. They appeared, at scale. Researchers still argue about why. Whether they're real phase transitions or measurement artifacts. The debate is open. So, is it just autocomplete? Technically, yes. Mechanically, the objective is literally next token prediction. Practically, something stranger happened on the way there. Here's the whole model, in one sentence. ChatGPT is a statistical model of language trained on a huge slice of human writing that predicts what token comes next, using attention to decide which earlier tokens matter. Everything else, the appearance of reasoning, the hallucinations, the capability to write code or poetry, emerges from that one mechanism, scaled enormously. Is it intelligent? That depends entirely on your definition. Does it understand you the way another human does? No. Does it produce useful, flexible, surprisingly capable outputs across a huge range of tasks? Yes. Those two facts are not in contradiction. They're the territory we now live in. The magic is real. The magic is also math. So, tokens, not words. Attention as the core innovation. Hallucinations as a direct consequence of training on plausibility, not truth. Capability as an emergent property of scale. That's ChatGPT. No magic, no hype. Just one of the most interesting pieces of engineering we've built. If this was useful, subscribe. More explainers coming, no fluff.